Hey guys, it's Chili here. Welcome back to Project Twin. Today we are going to be improving the management of our bullets. We're going to be adding some more behavior to our poos. We are going to be doing a little simple benchmarking of our game's logic and physics code. And we're finally going to fix that mirroring bug that we got in our sprites. The problem with the clipping when we're mirrored. Alright, get rid of OOB fireballs. OOB stands for out of bounds. So when we fire our fireballs, if they don't hit something like a poo, they're just going to go off into the ether and they're just going to be there forever, wasting cycles on our CPU. So we want to get rid of the ones that aren't relevant to the game anymore. So what we do is we get the screen rect and we check to see if the poo is still overlapping with the screen rect. If it isn't overlapping anymore, we remove that shit. It's no longer relevant, it's no longer visible. And here we adjust the spawn position of the poo. And this was just, let me think here. What do I want to do? What am I doing here? B spawn 0 minus. So I make it, instead of making it spawn around the feet, spawning more from the dick area. You will see that if I run this. Yeah, you see now the balls are spawning from the crotch, which is, you know, that's where they should be, I think. Crotch is an appropriate place for the balls to be. Look at how these poos all stack up. I don't like that. And so what I did is I changed the behavior of the poos so they don't stack it anymore. So I gave inside of the game update loop, created a boolean somewhere here called avoiding. And what happens is the poos, they check all the other poos, and if they are really close to any other poo, they enter an avoiding mode, and in the avoiding mode the direction of motion is away from that poo. So they generally try to follow Chili, but if they're too close to another poo, they try to avoid that poo. It's basically the way it goes. So you can see here now, when the poos start to get really close to each other, they are, well, I mean, they're not stacking up, but they're also kind of just, I don't know, they're getting in each other's way. There's a little bit of a bug in the poo self-avoidance code that we'll deal with in a little bit here. Now we've got a bit of processing going on here because, you know, we've got all the bullets being checked against all the poos and all the poos being checked against themselves, and I just wanted to see, you know, how much is this really costing me right now, just to get a ballpark idea. I don't think it's going to be an issue, but might as well. So I added a frame timer here, and at the end I just do a little bit of output debug string with the frame timer. So I'm checking to see how much this update is costing me every frame. And in order to make that a better test, I've did a mini stress test in which I think I basically just add a hell of a lot more poos. So I add, you know, 100 poos to the equation here. And if I run that, you see I got a lot more poos now. And let's just create a whole bunch of fireballs here. And yeah, we'll see how it works when we have a lot of fireballs and a lot of poos on the screen at the same time. So in the output window here, we can see the times here. These are in seconds, so this is 10 microseconds, which is, you know, it's not a lot of time. If we scroll up here, we can see higher numbers when there were more fireballs on the screen. It was going up maybe close to, sometimes you get anomalies, like 100 or 200, but those are just blips. But generally, even with a lot of fireballs up there and a lot of poos, maybe 20 microseconds. So I think we're pretty good. We're not going to have to worry about the updating. Here it looks like I've realized the bug with the avoidance code, and I have fixed it, I guess. So well, I changed the number of poos a little bit, back down to a sane number. And in here, what was I doing wrong? I have no idea. So normalize delta to get direction. Delta divided by length squared. Here's delta divided by square root of length squared. So I was using length squared up here. So because I was dividing by a number that was actually the square of the number I wanted to divide by, the end result was that the poos were moving excruciatingly slow. So if you run that, now you see that the poos are not stacking with each other, and they are also not slowing down like balls. They're going at a pretty good speed, at least. They kind of group up like that, which I like. This is pretty cool. Now, one thing you might notice is, like, when I go down here and then I try to shoot up, no fireballs appear. And the reason why they don't appear here is because the fireball tries to spawn outside of the screen region, and so it immediately gets culled. It's immediately out of bounds. So what I did for that, is I gave myself a little buffer zone, a little more space for the fireball to be alive before it goes out of bounds. And sound effects for my balls. Obviously, your balls are going to want to have sound effects. So what did I do here? Game.h, added fireball, added F hit. Play fireball when you spawn a fireball. You play F hit when fireball hits a poo. And also got rid of the bounding box rectangles. And then I just added a little tweak to make my balls faster. And if we run this, now we got faster balls. And I don't know if you can hear this, but I got sound effects on the fireball and when it hits the poo. It's easy to underestimate when you're making like a little prototype or something, the effect that just some simple sound effects can add to the feel of your game. So I recommend putting some of that in there just for your own entertainment and for anyone you want to show the game to get interest going. Now the next thing we do is we finally fix the mirroring bullshit on our sprite drawing there. So let us take a look at this, because this is going to be, you know, pretty important, a little bit in depth. So what we do basically is, before what we had all the clipping being done, then the test for reverse, and then it chooses either one of two for loops. Here, we do the test first, and that determines whether we're going to clip in one way or clip in another. So now we have two versions of the clipping and the drawing, because they have to be different depending on whether you're drawing mirrored or not. You can't use the same clipping for the two mirror cases. Alright, so we know that in mirrored drawing, you're going to scan left to right on the destination on the screen, as usual, but you're going to copy from the source, scanning right to left. And that will give you a horizontally flipped version of the sprite on the screen. Now let's say we're clipping our normal drawing sprite here to some clip region. To handle that is pretty straightforward, right? All you got to do is, well, you figure out how much you're going off the screen by, and you adjust your source rectangle accordingly, and now you only draw this sub-rectangle to your drawing position, and you're only going to draw this part here. But if we use that same clipping logic for the mirrored sprite, you can see the problem right away. We're clipping away this part here, the part that is with the teal eye. So that would clip away this part here, but we want to clip away this part. It's a bad situation. So we need different clipping depending on whether we're mirrored or not, and that was my problem. So here you can see, if not reversed, we're doing source right left plus clip left minus X, and here right minus clip left minus X. So it's all flipped around here, and this gives us the proper result. You can see if I go off the screen here, no bullshit, everything works fine. And that's about gonna do it for today. We're gonna be seeing more of this graphics theory and graphics algorithm type stuff as we move forward, because I'm gonna be wanting to add more and more interesting graphical effects to our game. And the nature of this problem, the software graphics engine, means it's gonna be a lot of work for us. We're gonna get our hands dirty. We're gonna need to know a lot of theory. We can't rely on APIs and shit like that. But it also means we're gonna have full control over every pixel that is drawn, so we can do some pretty interesting effects. Basically, your imagination and your skills are the limit. But I want you guys to let me know, how much detail you want to see in these kinds of graphical algorithms, because I can go pretty detailed, but it's going to slow down the videos, obviously. So let me know how deep and detailed you want me to get with these, with the graphical theory, the math, and the algorithms. Until then, thanks for watching. Hope you liked the video. If you did, please click the like button, it helps a lot. And I will see you soon with some more Project Twin.